Today we are writing trig equations from verbal descriptions as well as from a graph. So recall our general equation format. We have y equals a, the trig value, b times x minus c plus d. Now instead of the word trig, it could be sine, cosine, tangent, or any of the reciprocal functions. Problem number 1. It says we have a sine with amplitude of 2, a period of 3 pi over 2, a phase shift of left pi unit, and a vertical shift of 3. So let's go ahead and start writing that equation. So it would be y equals a. Here, what trig function do we need to write our equation as? Sine. So my equation, make sure an equation has an equal sign. You can use f of x equals or y equals. Now the a value would be the amplitude. And what do they tell us about the amplitude? It's 2. So for a, put a 2. Then it has to be sine. I'm going to leave the b value for right now. And what does this c value tell me? Yeah, the phase shift. Did it move left or right? And they told us in the problem it moves left pi unit. So how would I show my equation it moves left pi unit? Yeah, inside the parentheses you have to have x plus pi. Make sure you put the opposite sign. So if it moves left, make sure it's a plus sign. Now the d value, what does the d value tell me? Yeah, the vertical translation. So here it tells us a vertical shift of 3. Did they specify up 3 or down 3? No, but since it's a positive 3, I'm going to assume it was up 3. Now, the last thing in my equation, I can't just leave b. We actually have to figure out what the b value would be. And the b value relates to the what? Period. And if you recall, we do have a formula to calculate the period. We know that period is equal to the original period divided by the absolute value of b. So what we're going to do, we're going to use that formula and solve it for b to find the b value for our equation. So for this problem, they told us that the period is 3 pi over 2. So where it says period, we need to replace that with a 3 pi over 2. Now, what is the original period for the sine function? 2 pi. We need to divide that by the absolute value of b. Now, solving that equation for b, the first step would be multiply both sides by the absolute value of b. I'll come over here to finish it out. So that gives me the absolute value of b times 3 pi over 2 is equal to 2 pi. Now if b is being multiplied by 3 pi over 2, the opposite would be divide both sides by 3 pi over 2. So that gives me the absolute value of b is, this would be 2 pi over 1. Multiplied by the reciprocal, which would be 2 over 3 pi. And 2 pi times 2 is 4 pi. And 1 times 3 pi is 3 pi. And then pi in the numerator, pi in the denominator. Those will cancel. So that gives us the absolute value of b is equal to 4/3. So if the absolute value of b is 4/3, then the b value has to be 4/3. So back to my equation. Now I'm going to erase where I left just b. Instead of b, what do I use for b? 4/3. So there's my equation. Y equals 2 times the sine of 4/3. Make sure x plus pi is in parentheses, and then a plus 3 at the back. And I boxed in the absolute value of b. That's not part of the equation. Should have ended right there. Next one, problem number 2. Cosecant with amplitude of 3. Now, does cosecant have an amplitude? No, because it doesn't have a maximum. So here, when they're talking about the amplitude, they're just talking about the A value. And then it's reflected over the x-axis. The period is 4 pi. We have a phase shift right, pi over 2 units, and a vertical shift down 5 units. So for this one, if I'm using cosecant, for the cosecant function, our general form should be y equals a. For cosecant, it's CSC b times x minus c plus d. So starting with the a value, they said the amplitude, but cosecant won't have amplitude. So that would be our a value is 3. And how would I show that it reflects over the x-axis? Make it a -3. So -3, cosecant. I'll leave b for right now. We'll solve for b in just a moment. But how would I show that the phase shift is right pi over 2 units? Yes, x minus pi over 2 in the parentheses. And then for the d value, how do we show that there was a vertical shift down 5 units? -5. Now we have to solve for b using the period formula. And our period formula is period is equal to the original period divided by the absolute value of b. And they told us the period is 4 pi. And if we're talking about cosecant, what's the original period for cosecant? 2 pi. So 2 pi needs to be divided by the absolute value of b. So now we need to solve that equation for b. So the first step is multiply both sides by the absolute value of b. So that cancels over here. That gives us the absolute value of b times 4 pi is equal to 2 pi. What's my next step? Divide both sides by 4 pi. So that gives me the absolute value of b is equal to pi in the numerator, pi in the denominator. Those cancel. And 2 4 simplifies to 1/2. So if the absolute value of b is equal to 1/2, that means b is equal to 1/2. So over here, my equation, now I need to erase the b. And I need a 1/2. So y equals -3 times the cosecant of 1/2 times x minus pi over 2 in parentheses minus 5. Right, cosecant does not have an amplitude. Because that was the stretch factor, is stretched by a factor of 3. And it's a negative because it reflected over the x-axis. So here, instead of amplitude, they really should have said it was a stretch. It was stretched vertically. Okay, number 3, we have tangent with asymptotes at all multiples of pi over 4. And we also have a vertical shift up 4 units. So the general equation would be y equals a times the tangent of b times x minus c plus d. Now this one tells us that we have asymptotes at all multiples of pi over 4. Well, first, sometimes it's best if you look at a picture. So let me quickly draw the parent function. I know for tangent, I'm going to have vertical asymptotes at -pi over 2 as well as positive pi over 2. And then I'll have the cubic function in the middle. But they said that we have asymptotes at all multiples of what? Pi over 4. So instead of having them at pi over 2, we're going to also have asymptotes at pi over 4. So here's positive pi over 4 And we'll have another asymptote at negative pi over 4. And then all multiples of pi over 4, so right here would be 1 pi over 4. This would be 2 pi over 4, which would be pi over 2. So there's asymptotes at all multiples of pi over 4 between negative pi over 2 and positive pi over 2. So for tangent, it is cubic between those two vertical asymptotes, with the left arm pointing down, right arm pointing up. So this is actually telling me, when they told me that the asymptotes are at all multiples of pi over 4, they're actually telling me that what changed on the graph? The period, right? Because now what's the period? Pi over 4. So this is actually telling me that, hey, your B value changed. So if the period changed, that's your B value. Now looking from negative pi over 2 to positive pi over 2, this is 1. That is negative pi over 2 to positive pi over 2 is the length of one period of the parent function. But in the length of one period of the parent function, how many total cycles do we have? 4. So this is actually telling me the B value is 4. I have 4 complete cycles from negative pi over 2 to positive pi over 2, which is the period length of the parent function. So now I can start writing my equation. It's going to be y equals A. Is there a stretch or a shrink? No. Did it reflect over the x-axis? No. So the A value is 1. Then we'll have tangent. Here our B value is 4. We have 4 cycles of the tangent function from negative pi over 2 to positive pi over 2. Now for x minus c, do we have a phase shift? No. So really it would be just 4x. And then to show that a vertical shift up 4 units, we have to have a plus 4. So y equals the tangent of 4x plus 4. Okay, I want you to do problems 4 and 5. Come up with the equations for problems 4 and 5. For number 4, cosine with amplitude of 1/2 with a period of 3 pi over 2 and a phase shift of pi over 2 units right. So my general equation would be y equals a times the cosine. We'll have b x minus c plus d. So starting with the a value. What do they tell us about the a value? Yeah, the amplitude is now 1/2. Did it reflect over the x-axis? No, so it needs to be a positive 1/2. Then we'll have cosine. I'll leave the b for right now. X minus c. What did they tell us about the phase shift? Yeah, it's pi over 2 to the right. If it moved pi over 2 units to the right, how would I show that in the equation? X minus pi over 2. And d would be the vertical translation. And did the graph translate up or down? No, so the d value is 0. You don't have to put plus 0. Now solving for b, use the period formula. The period equals original period divided by the absolute value of b. They told us that the period is 3 pi over 2. What is the normal period length for cosine? 2 pi divided by the absolute value of b. Multiply both sides by the absolute value of b. So that gives me absolute value of b times 3 pi over 2 is equal to 2 pi. Divide both sides by 3 pi over 2. And that gives me the absolute value of b is equal to, I'll leave this at 2 pi over 1, change divide to multiply, and multiply by the reciprocal, which would be 2 over 3 pi. I'll go ahead and cancel the pi. Pi in the numerator, pi in the denominator, those cancel. That gives me the absolute value of b is equal to 2 times 2 is 4, and 1 times 3 is 3. So if the absolute value of b is equal to 4/3, that means my b value is 4/3. We're going to assume the b value is positive. If the b value were negative, they would tell us it reflected over what? The y-axis. So erasing the b, and for b, I need to put a 4/3. So y equals 1/2 times the cosine of 4/3. Inside the parentheses, we have x minus pi over 2. Last one on the front, problem number 5. Now this one's the tangent. It says tangent with a stretch of 2, a period of 3 pi over 2, and a vertical stretch, not a vertical stretch, a vertical shift down 2 units. So if I'm talking about tangent, my general equation would be y equals a times the tangent of b times x minus c plus d. Now, did this equation have any sort of vertical stretch or strength? Yeah. Where would the stretch of 2 go? For the a value. Did it reflect over the x-axis? No. So the a is positive 2. Then we'll have the tangent. I'll leave the b right here for now. For x minus c, did it translate, or do we have a phase shift? No. So I don't have to put x minus 0, it's just x. And for the d value, it translated down 2 units. Now to solve for b, use the period formula. So the period is equal to 2 pi divided by the absolute value of b. They told us the period was 3 pi over 2. It's equal to, why did I put 2 pi? I don't know. I was writing the formula. This should have been original period, and the original period for tangent is pi. So this would be pi divided by the absolute value of b. First step to solve that equation is multiply both sides by the absolute value of b. So the absolute value of b is canceled. That gives me absolute value of b times 3 pi over 2 is equal to pi. Divide both sides by 3 pi over 2. So that gives me the absolute value of b is equal to, I'll leave the pi over 1, change divide to multiply, and when I multiply by the reciprocal, it would be 2 over 3 pi. Pi in the numerator, pi in the denominator, those cancel. So that gives me the absolute value of b is equal to 2/3. So that means my b value is 2/3. So over here in my equation, I'll erase the b, and I replace b with 2/3. So y equals 2 times the tangent of 2/3 x minus 2. Now, do you have to have the parentheses here? No, probably most of you wrote it as y equals 2 tangent 2/3 x minus 2. So if you have the parentheses, that's fine. If you don't, that's fine too. Now on the back, now we are going to write equations from the graph. Now looking at the instructions, be careful you read the instructions. What do the instructions say? Write 2 different equations. So you have to have 2 answers. Now looking at number 6, what 2 functions would that look like? Cosine or sine. So let's write one equation as a sine and one equation as a cosine. So now we have multiple cycles, so you could pick any cycle given on this graph. So if I want to start with sine, I'm going to pick right here. Now if I were you, you might just want to kind of darken it in by putting little squiggle lines on it. And there's 1 period for the sine. And I'll put a 1 right here so I know this is my first equation. So when I write my equation, now this one is for sine. The a value, what is the distance from the middle of that graph to the top of the graph? 2. Did it reflect over the x-axis? No, it did not. And then we'll have sine. Now for the b value, what is the normal period length for sine? 2 pi. Well, if you look from 0 to 2 pi, how many cycles did my function make? 2. So the b value is 2. Now, for the phase shift, that sine function moved left or right? Yes, it should have been at 0, so it moved right. How much? How would I show it moved right? Pi over 4. X minus pi over 4. And then the d value, the x-axis translated up or down? Up how many units? Up 2 units. Now, that's one equation, but how many equations do I have to have? 2. So now, if I did sine, the next one I'm going to do would be cosine. So now I want to use this part of the graph. Again, on your paper, you can just put little squiggle lines to darken it in. And for this part of the graph, let's do cosine. Now the a value, that's the amplitude. So what is the distance from the middle of that graph to the top of the curve? 2. And we're doing cosine for this one. Now the b value deals with the period. What is the normal period for cosine? 2 pi. So how many cycles does it complete in 2 pi units? 2 complete cycles. So the b value is 2. Now, cosine should have started right here. So which direction did that function move? Left how much? 3 pi over 2. So how do I show it moved left 3 pi over 2 units? X plus 3 pi over 2. Now for the vertical translation, the x-axis translated up 2 units. It's up 2 units. Now looking at those two equations, how are they similar? The A values are the same. The B values are the same. The D values are the same. So the only thing that changed was the phase shift. And just think of it, just remember cosine is just a phase shift of the sine function. Okay, next one. Yes. Okay, so the question was, wasn't it moved up 3 units? So what we have to do is find the middle of the graph. So the middle of the graph, let me do that in blue. Here's the middle of the graph. So that's my new x-axis. So in relation to the x-axis, how many units are from here to here? 2. So the vertical translation was up 2 units. So yes, plus 2. Okay, next one. Problem number 7. This looks like what two functions? Tangent or cotangent. So for tangent and cotangent, I would deal with this one right here because I can see the complete period. So let's use this one period of the graph to write both equations. So on number 6, I chose 2 different segments, but you could use just one segment. And let me locate my critical point. So I have a point at negative pi over 2, negative 1. I'll have a point at negative pi 0. And I have a point at 0, negative 2. And the vertical asymptotes, I have a vertical asymptote at negative 3 pi over 2, as well as at positive pi over 2. Okay, so equation number 1. Which one does this look more like? Tangent or cotangent? Cotangent, because the left arm is pointing up. So let's do cotangent first. So y equals a. Do we have a stretch or shrink factor? No, from that middle point, we're only going up 1 unit. So it did not stretch or shrink vertically. Did it reflect over the x-axis? No. So our a value is positive 1, and we're writing a cotangent function. Now the b value deals with the period. So if I'm talking about cotangent, what is the normal period length of the cotangent function? Pi. So in pi units, here would be pi units right here. So for this cycle, from negative pi over 2 to positive pi over 2, I should have completed 1 full cycle. But, yeah, notice I only did half. So this would be half of a period. So for my graph that I'm given, it only completed half of the period because it's from the middle point to the lower arm. So that's only half of the period in the original period length. So here my b value would be 1/2. Now x minus c, I need to figure out the horizontal translation or the phase shift. If I'm talking about cotangent, this point in the center is normally at pi over 2. So that point translated which direction? Left pi units. So how would I show it moved left pi units? X plus pi. Now, which way did the x-axis move? Yeah, here's the middle of my graph. So the x-axis translated down 1 unit. So put a -1 at the back. So there's my first equation. I wrote it as a cotangent function. Now, I am going to write a tangent function on that same curve. So y equals, the amplitude is the same. It's still 1. But now for tangent, I know that the left arm should be pointing down and the right arm should be pointing up. So how would I show that? Negative. The a value needs to be a -1. So this would be the negative tangent. The period is still the same. I'm still completing half of a cycle in pi units. So the b value is still 1/2. Now tangent. For tangent, that central point is at the origin. So which way did that point move? Left.